Now you can contact us to um, get assistance with any subject or a chapter under each subject that you are having an issue with. So we have completed some number of subjects and chapters over here. We have covered chemistry, physics, and mathematics. We have covered some of the chapters. So you can contact us, right? Any student at all. Then you can WhatsApp us through this number, various number. If the first one doesn't go through, the second one might go through, the third one might go through. Contact us, and then you choose a subject and a chapter under that subject. They will connect you to a tutor to help you understand the concept and grasp everything around it so that you can master the chapter each time. Yeah, we hope to meet you guys and then work with you. Son has opened that portal for you. Now get in touch. Let's improve your understanding of the various concepts. Today we are going to solve questions on zeros of functions, which we have covered in the previous session. So let's complete these um, practice problems. So the very first problem is we have this. We have to find the zero of this function. So but based on the concept that we learned, right? We say to find the zeros, we focus on the numerator. On the numerator, right? So the focus should be on the numerator. Let me clean that. That's so big. Okay. But then since if the numerator is a constant, then the answer is no zeros. So for this particular question, there are no zeros for this particular um assignment or task. There are no zeros given. We cannot find a zero for this particular function because the numerator is a constant. Good. Let's go to the next one. This one is a negative constant as the numerator. We don't care whether we are positive or negative or square roots, or once it's a constant or it doesn't have the x term inside the numerator, then the response is still no zeros for this function as well. Okay, let's move to something else. Okay, for this one we have x minus 3 and then x plus 1 at the denominator. So we focus on the numerator. What we do is that we basically do x minus 3 equals to 0. That's what we talk about, right? We equate the numerator to 0. Then you do that, you have x is equal to negative 3 goes to the other side, become positive 3. So this is the final answer. This is the 0 for this particular function. Now let's solve another question. This question says f of x is equal to 2x plus 4 all over x minus 5. Okay, so as usual, we will focus on the numerator and equate the numerator to 0. So let's do that. It's going to be 2x plus 4 equals to 0. So we have 2x equals to negative 4 because the positive 4 will go to this side. Then x will be equal, divide both sides by 2. Then we have this one by 2, this one 2 by 2. You have negative 4 over 2 is going to be negative 2. So this is the final answer for this. So the 0 for this particular function is this one. Let's go to this one as well. So we have the numerator and denominator factorized as well. So already we have s minus 2 multiply s plus 1, blah blah blah, right? You take the numerator, s minus 2 multiplying s plus 1 equals to 0. So here it's factorized form, so it's just like we treat it as how we are doing factorization, or s plus 1 equals to 0. So you solve for it. You have s is equal to 2 or x is equal to negative 1. So the answer is x is equal to negative 1 comma 2. So this is the final answer for this particular question. These are the zeros of the function. Now let's move to something more. So we have this format, right? This format that the numerator and the denominator is factorized, the numerator is yet to be factorized. So what the first thing to do is to factorize the numerator. So you have s squared plus x minus 6. If you factorize this, the two terms that you may have over here for this 6 is 2 and 3, right? Especially positive 3 and negative 2 are the terms, right? When we are doing factorization. Good. So how do we do that? It becomes s squared plus 3x minus 2x minus 6. So if you factorize this, you are going to have x into bracket x plus 3 minus 2 into bracket x plus 3. So if you do that, the factorization will now lead you to x plus 3 multiplying x minus 2. So we have factorized the numerator now. So the new function, let me clean this side. The actual function that we have here after doing the factorization is something of this sort. So f of x is equal to x plus 3 multiplying x minus 2 all over x minus 4 multiplying x plus 2. So we are good. Now we have the factorized form at the numerator. So now we just equate it to 0, the numerator to 0, x plus 3 multiplying x minus 2 equals to 0. So you have x equals to x plus 3 equals 0, or x minus 2 equals 0. So you have x is equal to negative 3 or s equals to 2. So the final answer for x, so x is equal to negative 3 comma 2. So these are the answers for this. Now let's look at this one. This one, the numerator and the denominator are factorized for us. But there is something I want to show you first. So you see, usually we were doing equating just the numerator to 0, equating the numerator to 0. So you might be tempted to straight run and then go and then just do x minus 4 all over s plus 2 equals to 0 and be solving for it. Right? If you are not careful, you will get it wrong this time. So yeah, this is why I say that in this session the question will be a bit elevated, right? So we did it from the simplest one to this case. So it's not like you jump every time and make it equal to 0. Before you even make it to 0, you do something. You see, when I was even on this question, I had to pause, factorize the numerator, put it back at this on the numerator before I proceeded, because I was checking something. What do you check? What you check is that, you see, you have to check if the numerator and the denominator has the common factors, right? Common factors. So if you can see the denominator very well, it has x minus 4 as a factor, multiplying one factor here, and the numerator too has x minus 4 multiply another factor, x plus 2. So they have x minus 4 the numerator as a factor and x minus 4 the denominator as a factor. That's what you have to check. If some factors are common, if those factors are common, then you can cancel them out. So if you cancel this thing out, so basically cancellation happens before you proceed with finding the zeros. Before you equate the numerator to 0, the actual thing is that you have to make sure that you check if any cancellation can be done, right? So here you can cancel this, right? Let me write it new here. F of x is equal to x minus 4 multiplying x plus 2, right? They have, and then this one has a denominator factor, x minus 4 multiplying x minus 1. So this factor is the same as this factor, so they cancel out. So the function just reduces to x plus 2 all over x minus 1. It is this reduced form that we now focus on, just making the equation, the numerator equal to 0. So become x plus 2 equal to 0. So s is equal to negative 2. So this is the only 0 for this particular function. So if you look at the one we did earlier, right, there's the numerator does not have a factor that cancels the denominator. When we look at this one too, the numerator doesn't have anything that cancels any factor in the denominator. So we just proceeded to make this. But when we come to this case, there's a common factor. You need to make sure that you cancel the factors first. So when you have a format like this, make sure you factorize them. After you factorize them, you put them back like this to check if, so I was checking if some factors at the numerator is going to cancel any factor in the denominator before I proceeded. So since there was no cancellation, I just proceeded to find the zeros, right? So now that we have that knowledge, let's proceed to this particular one. So you have this, right? The numerator is not factorial, but there we have one factor, which is s plus 2 at the denominator. So here you have s squared minus 4. S squared minus 4 can be factorized if it's a difference of two squares, right? So f of x. So if you factorize the numerator, difference of two squares, right? We've done that, s plus 2 multiplying x minus 2. This is a factors of 2 square, right? So divided by s plus 2. So s plus 2 is a factor at the denominator and it's also at the numerator. So this one will cancel this now. So the function now reduces to s minus 2 all over 1, which is the same as just s minus 2, because anything at the denominator we don't care much. So the zero of this function will just be using s minus 2 equal to 0, because that's the only numerator that is left right after the reduction. So s is equal to negative 2 is here, it goes here, become 2. So this is the answer for this question. Okay, let's look at another question. So you see that, okay, this one, the factors, all of them are not factored, none of them is factorized. So I'm going to take the numerator, factorize it. So we factorize it already, we've done it. This is s plus 3, right, multiplying x minus 2. I've done that process when I was factorizing it here. It's the same thing here. When I'm factorizing this, then we got this, right? That's why I just remembered and copied it. And the denominator, you factorize the denominator, right? So you have s squared plus 2x plus 1. This one is 1 1, right? So it become s squared plus x plus 1. So you have x multiplying s plus 1 plus s plus 1. So the factors are s plus 1 multiplying s plus 1. So it's basically s plus 1 squared, right? So it's s plus 1 squared at the denominator, or more s plus 1 multiplying s plus 1. So I knew that would be the answer, but I just wanted to show you. So it become s plus 1 all squared, right? Or you can write it as numerator is s plus 3 multiplying x minus 2 all over x plus 1 multiplying s plus 1 again. So you see, now that we have the full form of it, the numerator and denominator factorized, there's no common term that is at the there's no common term between the numerator and the denominator. Since we are sure that there's no common term, now we can proceed to just take the numerator and then find the 0. So we become s plus 3 equals to 0, or s minus 2 equals to 0. Then you have x is equal to negative 3, or s is equal to 2. So the zeros are s is equal to negative 3 comma 2. Yeah, this is how to find the 0 for this function. Let me look at another one. Okay, so this one still we need to factorize. For the numerator, this is a cubic, right? So you do x into bracket s squared minus 1, that's for the top. Then the bottom is a difference of 2 squares. For difference of 2 squares, is going to be x minus 2 multiply x plus 2, right? So in this one too, you can see that the numerator is also difference of 2 squares again, right? Difference of 2 squares again. So what we do is that we can have x into bracket s minus 1 multiply s plus 1. That's for the one in the bracket here, right? So difference of 2 squares, that's how we solve it. You've done it under polynomial function. You can go back and then look at those chapters, how to factorize doing difference of 2 squares and all that. S plus 2. So you see there's no common term between the numerator and the denominator. For that matter, we can now safely proceed and then just take the numerator and then equate it to 0 and solve for our question. So equal to 0. Here, x, there are 3 terms. So s is equal to 0, or s minus 1 is equal to 0, or s plus 1 equals to 0. My table is getting full. Let me clean this and send this up, right? Let me send this up. Okay, so we are here now. So I know s is equal to 0 is already correct. S is equal to 1, or s is equal to negative 1. So the answer will be x equals to negative 1 comma 0 comma 1. These are the zeros for this function. Okay, let's solve this one too. So already this one is also clean, right? It's already factorized. You have s plus 1 and s plus 1 in the numerator here. So this one will cancel this, right? Because they are common factors. Since they are common factors, we are now the function now changes back to something like s minus 2 all squared. This is all squared, so it's not the same as the difference of 2 squared, so be careful. S minus 5. So if you have this, what do we do? We now take the numerator and equate it to 0, so it become s minus 2 all squared equal to 0. So you have x minus 2 equals 0, so s equals to 2. So the answer is s equals to 2. This is the 0 for this particular function as well. Now let's look at this one. So looking at this one also, you can see that we have common term 5 multiplying a factor, right? S minus 1, and there's s minus 1 as a factor, the denominator. So we cancel those factors, right? So the function now gets to the numerator, it is left with 5, and the denominator, it is left with s plus 2. Now we need to find the 0 of this. So see here, the simplified function, after doing the cancellation, the simplified function is such that the numerator is just a constant. So what did we say when the numerator is constant? The answer is no zeros. So there are no zeros for this function. Basically, there are no zero for this one because the numerator, after doing the cancellation, the numerator is having a constant 0. Yeah. So this is a full fledged of finding the zeros of a function, and now we have solidified the concept, right? Yeah. So we're taking our time to solve everything and explain why every action is needed. Let's meet in another section and continue more operations on rational functions.